So today we're going to go over how to solve systems of equations by graphing. So you should be taking notes on this page of your handout. So let's go ahead and get started. Make sure to pause at any time where you need more time to get something done. So let's get started on the actual notes now. So pretty much systems of equations is when you have a collection of two or more equations with the same set of variables. As we can see in example number 1, we have the first equation, we have the second equation. Each of them has a variable x and a variable y, which makes them each a system. So we know that the solution to the system is where the two lines intersect. So let's go ahead and graph these two equations. Again, there's not much of a difference. We're just putting two lines on the same grid as opposed to just one line. So we start by looking at our first equation. We identify our slope, which is -3/2, which is going to be a decreasing line. And we're going to start at the number 2 on the y-axis. So let's go ahead and put our point at 2 on the y-axis. From there, we're going to rise -3, so we're going to go down 3 and run 2 forward to the right. We're going to go down 3 and over 2. Down 3 and over 2 until we can go no more on our grid. So we're going to get quite a few points there. And then we'll work backwards. We're going to go up and back 2. So we're going to go up 3 and back 2. And we get all our points on our grid. Once we have that, we're going to go ahead and connect our line. So now we're going to repeat the process, but now we're going to put a second line on the same xy plane. So we're going to now go ahead and graph 3/2 x minus 4. Slope is 3/2 positive, so that means it's going to be increasing. And our y-intercept is going to be -4, which means we're going to start on the y-axis at -4. So we'll go ahead and put our point on the y-axis at -4. And from there, we're going to go up 3 and over 2. And then we're going to go up 3 over 2 until we can go no further in both directions. Once we have all our points, we're going to go ahead and connect our line. Once we connect our line, we're going to see the point of intersection, which is where our solution is located. Remember, our solution is where the two lines share an x and y value, which would be at the point of intersection. In this case, what is our point of intersection? We write it as a coordinate pair. It's going to be 2, 1, -1. So this is our point of intersection at 2, -1. Go ahead and pause it if you need to write this down. Otherwise, I'm going to go ahead and continue. We're going to have the same process on number 2. The only thing we notice on number 2 is that one of them is in standard form and the second one is in slope-intercept form. So we're going to need to take our first equation and convert it to slope-intercept form, meaning we need to solve it for y. Remember, it's just 2 steps. Move the x to the right and then divide by the number next to the y. So I'm going to move the x by subtracting it over on both sides. Remember, it does not combine with the -6, so I'm going to move it off to the side. The x's cancel, and I'm going to bring down my -x minus 6. Notice I just switched the order, but it's the same thing. Now I'm going to get the y by itself by dividing by 2 across the board. So when you divide by 2, the 2's cancel on the left side, which simplifies the y to itself. And on the right side, the x has an invisible 1 next to it, so it's a -1 because it's a -x. So it's going to be -1/2, and then divide 2 into 6, which gives us a 3, and it's -3. So we've converted our standard form equation to slope-intercept form so we can graph it. So my slope is -1/2, which means it's going to be a decreasing line starting at -3. So I'll put my point at -3 on the y-axis. From there, I'm going to go down 1, run to the right 2, down 1, run 2, down 1, run 2. So we just go ahead and fill our graph up with these points. Once we run out of space going one direction, we go in the opposite direction, up and back, and connect our graph. So we have our first line. Second line is in slope-intercept form, which is the preferred way of having it, because we can easily identify the slope and the y-intercept. So the slope is -1/2. Which means it's going to be decreasing as well. And our y-intercept is going to be -3, which means we're going to start at -3 on the y-axis. So we'll start at -3 on the y-axis, and then we're going to go down 1, run 2, down 1, run 2, down 1, run 2. As we notice that it's got the same slope and the same y-intercept, so it's going to be hitting the same exact points. So as we graph it, we're going to be going down 1 over 2. It's going to be hitting the same exact points on the graph, which means when we connect it, we're going to get a same line on top of the one we previously had. So it's the same equation, which means it's the same line twice. So remember, the system's solution is where the two lines intersect. In this case, they share every single point on the line. So every single point on the line is actually a solution, which means we have a whole bunch of solutions because this line will go on forever in both directions. So the way we write this, because we cannot actually write out every single point because they go on forever, we write down, what is the solution? We don't write down every point. We write down that there's many answers. Every single point on the line is a solution, but instead of writing that large phrase, we just write down infinitely many solutions. Remember, infinity means something that goes on forever. So we have that many solutions. We cannot count them. We need more time to write this down. Pause it, otherwise we're moving on. All right, third example. We have two lines. One's in standard form and one's in x equals to 3, which is one of our vertical lines. So x equal to 3 is just a line that crosses the x-axis at 3. All the x values for every point is going to be 3, which means it's a vertical line. So just as a side note, in this case, x is always going to be 3. Y can be any number we want. So in this case, when we graph this, it's always going to be 3 to the right and put a point. 3 to the right. It can go up or down whatever amount we want, so we can put a point anywhere we want here. Because all of these points have 3 in their x value, the y value doesn't matter. So in this case, we just have a vertical line. So when you have just x equal to 3, it's a vertical line crossing the x-axis at that point. All right, so let's go ahead and graph that line, just a vertical line at that point. Our second equation is in standard form, so we need to go ahead and change it to slope-intercept form. Remember, 2 steps. Move the x from the left side to the right side to get y by itself, and then divide by the number next to y. In this case, we're going to subtract 2x on both sides, which will eliminate it from the left and move it to the right side. So we have -2x and a +3. Again, there's no actual number written in front of the y, it's a -1, so we divide everything by -1. Dividing by -1, all it does is change the sign, so the -2 divided by -1 is positive, and 3 divided by -1 is negative. So we end up with 2x minus 3. Let's go ahead and graph this line, whose slope is 2, and y-intercept is -3. So we'll begin at -3 on the y-axis. Our slope is 2. And if we write it as a fraction, we're going to get 2 divided by 1, which means we're going to rise 2, run 1, rise 2, run 1. So here's rise 2, run 1, rise 2, run 1, and so on. We keep on going until we run out of room. Rise 2, run 1, going backwards as well. Let's clear that one out. So we just go ahead and finish up all the points. Once all the points are finished, we just go ahead and connect that line. Actually, I think I have a nicer one. Let me clear this one out and do it over again. There's the nicer line. So we have our two lines. One's a vertical line because of the equation x equal to 3. The other one's just a standard slanted line. And both lines meet at 3, 3. So our solution is 3, 3. All right, that's our last of the graphing examples, just realizing that when we have overlapping lines, we call that infinitely many solutions. Let's go ahead and get into number 4. That's going to be on the next page of your handout. So we have Amaya and Monica work part-time at 2 different shoe stores. Amaya earns $40 a day, plus $10 for each shoe, so she can earn a whole bunch of $10 based on every pair she sells. Monica is in the same situation, but she earns $60 guaranteed for the day, but only $5 per shoe. And we're going to let X represent the number of shoes. So we're going to go ahead and write the equations that represent the situation. So the system of equations, one equation for Monica and one equation for Amaya. So let's go ahead and start with Amaya. She earns $40 a day, so that's her starting value. That's her y-intercept, because that's guaranteed. And $10 per shoe, so that's the repeating value. That's going to be the change, or slope. So her equation is going to be y equals 10x plus 40. For Monica, she's guaranteed the $60. That's her starting value. Her y-intercept plus $5. That's her rate of change selling shoes. So it's going to be 5x plus 60. So this is our system of equations. Now we're going to go ahead and graph it. So we're going to label our graphs. X represents the number of shoes sold. Y-axis represents the money they earn. We're going to go ahead and graph this. Now we have pretty big numbers here, so we're going to have to rescale our y-axis. So our x-axis, we'll just go by 1. I'm not going to write all the numbers down, but go ahead and write them down. And our y-axis is we're gonna go by tens, just because I see 40s and 60 here and $10. And the $5 we can go in between. So we're gonna graph each of these y-axis by tens. So go ahead and put the 10, 20, 30, 40 on your paper. So we're gonna go ahead and graph this. Now we're gonna start with the first equation. It starts at 40. So I'm gonna put a point at 40. That's 4 boxes up, because they go by 10. And we're gonna rise 10 and run 1. So remember, each box going up is 10, so I'm going to rise 1 box, which represents 10, and I'm going to run 1. So I'm going to go up 10 and over 1. So me going up this direction shows up 10 over 1, even though it looks like I'm going up 1 over 1. It's just because I'm going by tens. So this one's just going to pretty much look very linear here, like going up 1 and over 1. And notice my arrow doesn't go to the left side. There's no negatives here. Let's go ahead and graph the second one. Starts at $60 for Monica. She automatically is guaranteed 60 bucks. And from there, we're going to go up 5, which is up half a box, because each box is 10. Each unit is 10 in this case. And we're going to run 1 over. So I'm going to go up half a box and over 1. I'm going to go up half a box for the $5 and over 1. Up half a box and over 1 until we're done all the way across. And then we go ahead and connect our line. Then we look for our point of intersection. So our point of intersection is going to be at 4 to the right and up 8, which would represent 80. So our solution is 4, 80. Now, what does this mean in terms of the problem? That means that for every 4, again, X represents the number of shoes. For every 4 pairs of shoes she sells, or they sell, they will earn $80. So for the last question is, how many shoes do they need to sell to make the same amount of money? Is they would each need to sell 4 pairs of shoes to earn a total of $80. All right, that's pretty much it for the notes. So go ahead and make sure you wrote everything down. Make sure you're not missing any of the work, and your task is now to fill out this, putting it all together. You're going to look at the 3 steps on the left, put them in the correct order of graphing. Once you're done with that, last page has 6 practice problems. Once you're done with that, there is an extra credit on Desmos, or you can go ahead and finish your performance task, which is due tomorrow. All right, go ahead and good luck.